Okay, good morning. So today we actually officially start one of the main topics in chapter 1, which is number theory. And we will start with the topic of divisibility. It's extremely simple, but I want to deviate a little bit from the one which is written in the book, then we will at the end converge, okay? And I told you that what you need to be able to do for the exam is just the problems in the book, okay? At the level of the book. So I will start with a definition. I write things a little bit rigorously and then try to motivate you, or probably describe it in simpler words. So let's A and B. So I underline them so to denote that these are variables in mathematics, not English letters. Okay, so let A and B be integers. We say that B is divisible. This is the word that I'm going to define. B is divisible by A, or, this is a little bit unusual for you probably, or A divides B and write, this is the symbol that we use, which is not in the book, but this is the standard one. You write A on the left and you put a vertical line in front and then put B on the right hand side of this vertical line. And we write if there exists an integer, I emphasize the word integer, Q, such that B is equal to A times Q. Something that in mathematics you need to get used to is that sometimes the concepts are so simple, but if you want to express them precisely, it seems a little bit complicated. So it's important, if you want to be a good mathematician, to be able to write precisely, and on the other hand, you should also understand the concept so you are not lost with the words and sentences or structures, okay? So it's extremely simple. Let me just, everyone probably knows the word divisibility or divisible or divisible, so probably this is the only new way of expressing the same thing here for you. So for example, let us consider two numbers, 6 and 2. Extremely simple. Everyone knows that 6 is divisible by 2. Yes? And then we say, let us consider the same, another pair, 5 and 2. So you know that 5 is not divisible by 2. So this is not something very strange. But why do you think 6 is divisible? If I ask you, how did you understand that 6 is divisible by 2, then what will be your answer? Why 6 is divisible by 2? Yes, please?
It's an even number.
So let me change it. So why? So let us talk about 6 and 3, 5 and 3. So why 6 is divisible? But how do you know? I'm not saying, I mean, how do you know? If I give you two numbers, 6 and 3, and I ask you, do you think 6 is divisible by 3? I would say that 100% you will say yes. But what process happened in your mind so that you said yes? Yes?
So I just think of the times table.
Yeah?
Multiplication table, and just think that 3 can fit in 6 2 times.
Yeah, that's good. What's your answer?
Saying that it can be multiplied by 2.
Or, I mean, so probably the most natural one, which is written in the book, is to divide 6 by 3. It becomes 2, and 2 is an integer number. Yes? So we say that 6 is divisible by 3. This is the way that the book has actually described that. Because if you divide 6 by 3, it becomes 2. 2 is an integer. Why 5 is not divisible by 3? Because if you do the same thing, you divide 5 by 3, it becomes 5 over 3, but 5 over 3 is not an integer. So in principle, that's the same concept, but we want to write it more rigorously. So we say that 6 is divisible by 3, because if I divide 6 by 3, the answer becomes 2, and everyone knows that 2 is an integer. Do you remember? These are the symbols that I actually frequently use. This symbol is the Greek letter epsilon, and it means, in mathematics, it means 2 belongs to, and this symbol was reserved, if you remember, for the set of integers. So we say that if you want to read it, we can say 2 is an integer, or you can say 2 belongs to the set of integers. So the reason that 6 is divisible by 3 is this. And then if you do the same thing here, if you divide 5 by 3, it does not belong to the set of integers. So this is the reason, actually, or actually this is the definition of divisibility. But I want to deviate a little bit. This is the way the book has described it, which is correct. But of course you know that we have to exclude 0. We have to exclude 0 here in this case, because in the denominator you cannot have 0. Yes? So in that case, if I want to follow the book's definition, here I have to mention that let a and b be integers, but I have to emphasize that a is not 0, then it is equivalent to this definition. But I want to deviate a little bit from it. But I mean the idea is clear, yes? Yes. Or now let us go back to what you said, which is exactly according to what I'm describing here. You can say that 6 is divisible by 3 because you can find an integer which, when multiplied by 3, gives me 6. What that integer is? So you can find an integer so that when you multiply it by 3, it becomes 6. What is that integer? 2. That's the way that you mention it, and I want to follow that here. So we say that 3 divides 6. So remember, if you want to read it from left to right, you read 3 divides 6. But if you want to read from right to left, you have to say that 6 is divisible by 3. Since 6 is 3 times 2, but this is not enough, and 2 belongs to the set of integers. That's it. So from now on, if I ask you why 6 is divisible by 3, if you want to express it really officially, this is the way that you have to write it down. But quickly, as a rule of thumb, I myself also prefer to divide 6 by this number to see if it's an integer or not, to be able to answer very quickly. Yes? So if someone asks you, how do you read this? Let us practice this a little bit. So 6 is divisible by 3, which is the word probably you are getting used to, but in this course I mainly use this, and I read it from left to right, and I write 3 divides 6, meaning that 6 is divisible by 3. So these are not very important things. I'm just introducing some words for you. Any questions? And you can interrupt me whenever you don't understand, and please do that. Any questions so far? Okay. So for example, why 5 is not divisible by 3? Because if you want to write 5 as 3 times some number, what that number is, by the way, there is one number that you can put here, so that this equality becomes true. What that number is?
5 over 3.
5 over 3. This is the only one, but 5 over 3 is not an integer. So 3 does not divide 5, or 5 is not divisible by 3. Again, I repeat, this is a very much faster way of understanding things. Just divide them. If the answer is an integer, It is divisible. If not, it's not divisible. Okay, so for example, can I say that minus 5 divides 25? Is that true or false?
True.
Is it true? Yes. So how do you express it? This is true since 25 is equal to what? The number on the right is equal to the number on the left multiplied by what? Minus 5. Okay? But if you stop here, it is not complete, and you should continue and write and what?
Minus 5 is an integer?
Yeah, minus 5 is an integer. So that part is extremely important. The whole notion of divisibility depends on the result to be an integer. So that's extremely important to emphasize on it. Okay, so what about this one? Can I write 2 divides 0? So as a rule of thumb, immediately answer true or false before doing writing those complicated things. If you want to see if this is true or false, take the number on the right in your head and then divide it by the number on the left. 0 over 2. What the answer is?
0.
And 0 is an integer. So this is true. Yeah. So this is the fastest way to do it. Okay. So this is true. Okay. But if you want to write it precisely, you write since what? The number on the right is equal to the number on the left multiplied. That is your duty to fine-tune that number. What number is that? 0. But you should continue one more and write what? 0 belongs to z. Okay, what about the other way around? What do you think about this sentence? This is statement, not sentence. In mathematics, declarative sentences which are either true or false are called statements. Yes? So this is a statement. This tells you that 0 divides 2 full stop. So this is a declarative sentence. It can be either true or false. So that's called a statement. So is this a statement true or false? As a rule of thumb, you put 2 on the numerator and then divide it by 0. It's meaningless. Okay, so probably this is false. But if you want to understand it, false. Why is that? Because is it possible to write 2 on the right equals to the number on the left multiplied by some question mark, which is supposed to come from the set of integers? Is it possible to fill up that gap? No. Because no matter what you put in the question for the question mark, if you multiply it by 0, it will not end up to be 2. It has to be 0. So it's not possible to find this. Okay, so it's not possible. So this is false. But there is a little bit different. So what do you think about this? So we cannot find that. You cannot find it. Yes. Okay, and what do you think? This is a little bit of deviation between. So I mean, they are not completely equivalent. 0 divides 0. True or false?
True.
If you want to use the definition in the book, the definition of the book is not capable of answering this, because in the definition of the book, they have already excluded the denominator from being 0. Yes. But do you think in our definition, in this way of defining, this statement which tells you 0 divides 0 itself is true or false? True or false? Yeah? It's true. How can you defend yourself?
Because it's divisible by itself.
No, we cannot say. That's the whole point. So you have this idea in mind that every number is divisible by itself. 2 is divisible by 2, 5 is divisible by 5, 7 is divisible by 7. But is 0 also divisible by 0? If you want to follow the definition in the book, you cannot answer this question, because in the definition in the book, 0 is excluded from the denominator for obvious reasons. Yes?
Since 0 times 0 would be 0, it's an integer.
Yes, so in principle, whenever you want to answer this one, so was it true or false? I didn't.
True.
True, yes. So you would say that if you want to see if this is true or false, you need to put the number on the right you put equality, you put the number on the left, and ask yourself, can I find an integer so that this is satisfied? If you can find at least one integer, then it is true. If you cannot find any integers, it is false. But can you find an integer instead of the question mark?
Yes.
And by the way, in this case, how many integers you can find? Infinitely many. So it doesn't matter what integer you choose, this is completely valid. So based on this definition that I have written here, we can consider this also to be true. Yes?
But based on that definition, wouldn't that mean that 0 divided by 0 is, I don't know, 100?
No, that's not. So that's exactly the reason. Even though that's exactly good, that's a good question. Here, if I want to divide 0 by 0, for example, if I divide 6 by 3, I get this 2, okay? And in this definition, 2 is the number that I was looking for. Here, there is no specific number that I can answer. The answer can be any number. So that is why it is undetermined to talk about 0 over 0. Because according to that definition, it could be any number. Yes? So that's not defined. So be careful. Whenever you have 0 in the denominator, if I ask you what that is, you should say it's not defined. But I want you to understand that there's a little bit delicate difference between these two situations. So I am not using division. I am not using division. Yes, I am not using division to define divisibility. I am using multiplication to define divisibility. Is that okay? So that's extremely simple. But one thing that I want to also you learn from this course is using mathematical symbols a little bit. So we say that A divides B, and then I put this symbol if and only if. So when I put if and only if between two statements, I mean that these two statements are mathematically equivalent, not identical, completely equivalent. So let me give you an example. So, for example, I say that for all x, by the way, this means for all. This upside down means for all. So for all x, if x squared is 4, then x is 2. Okay? So this is a statement telling you that whatever you choose for x, if this is true that x squared is 4, then this implies x is equal to 2. Is this a statement true or false? Yes? It's false. Yes, why is that?
Because it can be minus 2.
It can be also minus 2. So if you say x squared is equal to 4, then x is equal to 2. This statement is false. Of course, if I write this, let me just try to ask some questions to pit your appetite. Okay, so for every x in R, this is false. Can you change this one so that and then keep the same thing and then it becomes true? For example, I want to write for all x and I want to repeat this, but this time I want to keep it, I want to make it true. What should I write here as my set, for example? Yes, Aaron?
For all n.
For x belonging to n. Because if I say for all x in the set of natural numbers, if x squared is 4, I am always telling you that x is a natural number, and I am telling you that x squared is 4, then the only possible case is that x equals to 2. So it's extremely important to really pay attention to the details. So you see that this sentence, this statement is really similar to this statement, unless I have changed the domain of my variable from the set of real numbers to the set of natural numbers. It was false, but this one turns out to be true. Okay, but let us stick to the set of real numbers. So x squared equals to 4 implies x is equal to 2 is false if I am working in the set of real numbers. But still assume that I am working in the set of real numbers. What do you think about this? I am working again in the set of real numbers. What do you think about this? True or false?
True.
It's true. Okay? So be careful. it's extremely important to understand this from mathematical point of view. If this is a statement, let me call it P, and this is another statement, let me call it Q. If P, then Q. You read it like this, or you say that P implies Q, okay? If this is a true statement, of course. If P implies Q, there is no guarantee that Q also implies P, as this example shows. It might be true or might be false. Is that clear? So if P then Q is a true statement, on its own it is not enough to immediately jump to this conclusion that this way of writing is also true. By the way, this is called the converse. Yes? The converse. So if P then Q, if I ask you write the converse, I mean to write if Q then P. That's called the converse of that statement. This is called a conditional statement. Okay, so this is not true. So this is true, the other way around is not true. So I would say that this statement from mathematical point of view, if I am working in R, is not equivalent to this statement. Yes, they are not equivalent, they differ, yes? They are not the same thing. But let us write this one. Let us keep a little bit of space here. So if I write x to the power of 3 is equal to 8, still I am working in the set of real numbers. Can I conclude that x is 2? True or false? In this case, it is true. Yes, if x to the power of 3 is 8 and I am working in the set of real numbers, there is only one answer to that, and that is x equals to 2. But what do you think about, so this is true. True. What do you think about the other way around? This is true or false? This is telling you that if x is equal to 2, then x to the power of 3 is equal to 8. True or false? True. True. So you see that both the statement and its converse are true. So this means that when this happens, there is no difference between this statement and that statement whatsoever. Yes? So you can say that x equals to 2 if and only if x to the power of 3 is equal to 8. So they are completely equivalent mathematical statements. But the point is that which one is easier? X equals to 2 is easier than x to the power of 3 is equal to 8. So that is one duty of mathematics, to be able to discover statements which are simpler but are equivalent to more complex statements. Yes? I'm just talking about these things that I want you to know. So when we say that from here I can conclude this and from here I can conclude this, then I would say that x is equal to 2 if and only if x to the power of 3 is equal to 8. And then another way saying, instead of saying if and only if, I can say that this statement is equivalent to that statement. And this is the way that I am using it. Okay. So, and then if and only if, in math text, you usually see that IFF. Don't consider this as a misprint. Yeah, usually people are lazy, so instead of writing if and only if, they write IFF, means if and only if. Okay, so this, if it appears in math text, don't think that's a misprint. Okay, so A divides B if and only if there exists this reversed form of letter E, means there exists. Yes. There exists a Q, but where? In the set of integers such that, this is such that, a semicolon, such that the number on the right is equal A times the number on the left times Q. So this is the short way of writing those that long sentence here, or long sentences. So it's better to write, to get familiar with the symbols. By the way, it's not good to write everything, because some people are going to the other extreme. They try to write everything in mathematical symbols, which is not correct. If I show you a research article, you see that mathematicians write a lot of English words and then a little bit of formulas also there. So you have to have a balance. So don't think that writing everything in symbols is actually very beautiful or nice. It's not. Okay, but is that clear? You see that I have done nothing except just explaining things in a little bit proper way. Okay. Yes.
Okay, but if there's two type of answers for B, then
No, A and B are given in the beginning.
Mm.
You cannot change them in the book. I give you one A, I give you one B, then I can ask you a question.
Okay.
Yes? Depending on the values of A and B that I am giving you, if these are not these extreme cases, yes, then you will get only one unique answer for Q. But in these very extreme cases, you might get infinitely many, or not at all. Okay. Okay, by the way, from now on, when I talk about numbers in number theory, I always by default mean integers, unless I want to emphasize that no, they are not integers, okay? So whenever I talk about numbers in number theory, I try to remember every time to mention it, but sometimes I forget, but I mean the integers. Okay, so let me give you a very simple example to try to get used to these symbols and notations. Okay, so example, determine all possible, so you don't need to write possible, just all integers n such that let me see, 4n plus 3 divides minus 7. So that's very simple, yes? So I'm asking you to find all possible integers n so that when you multiply that n by 4 and add 3 to it, then it becomes a number which divides minus 7. Divides minus 7, it means minus 7 is divisible by that number, okay? But that is extremely simple. You really don't need that to be very, very precise in writing. Everyone should be able to know that. So you want to have a number. So this number is missing for you in total. But you want to choose this number in a way that minus 7 is divisible by that number. There are not that many options. You can immediately understand what are those numbers. So what are those numbers? So I would say that 4n plus 3 divides minus 7, this implies that there are not that many possibilities for this number. What are those possibilities?
7
One of them is 7.
minus 7,
Minus 7.
1,
1. Negative 1. These are the only ones because 7 is a prime number, yes? It's a prime number, so its divisors are either 1 or 7, but because you are working an integer, so that's also true. So you can say that 4n plus 3 is either minus 1, or I will use this symbol for or. 4n plus 3 is 1, or 4n plus 3 is minus 7, or 4n plus 3 is 7. So if you want, let us write like this. But of course, can I change it to this double-sided arrow or not? So this was clear that in this direction I can go. If you tell me this is happening, then I am allowed to conclude either one of these is happening. Yes? And now I'm asking you, if either one of these things are happening, can you go back and conclude that this is also true? If one of these things is true, can I conclude that this one is true?
Yes.
Yes. Because if you tell me that 4n plus 3 is minus 1, then of course minus 7 is divisible by minus 1. If you tell me this is true, I can conclude. So that is a double-sided arrow. So this means that this one single statement is equivalent to combination of these 4 statements. Yes? Okay, and then if instead of this one, I can forget this one and work on this equivalent one. So then I would say that let me understand what happens here. 4n plus 3 is equal to minus 1. Then what is my answer? 4n is equal to minus 4. And then what can I conclude? That n is equal to minus 1. Is minus 1 acceptable? Yes, because the problem is asking about integer n's and minus 1 is an integer. That's one solution. Okay, and then the other one, 4n plus 3 is 1. What can I conclude? I can conclude that 4n is minus 2, and then when I divide, n becomes minus 1/2, which is not acceptable. Yes? Because minus 1/2 is not an integer, and the problem is asking for integer n. Okay, and the same story. So 4n plus 3 is equal to minus 7. Then what happens? 4n is equal to minus 10. Then I can conclude that again n is minus 5/2, not acceptable. And then finally 4n plus 3 is equal to 7. Then it means that 4n is 4. It means that n is equal to 1. And that's it. So what is the answer to this question? So I would recommend you to try to learn to write the final answer. So determine all integers n. So what I write as an answer is n equals to minus 1 or n equals to 1. These are the only possible numbers that you can imagine. So that when you replace n with those numbers, the left-hand side divides the right-hand side. Extremely simple problem, yes? Yes.
Couldn't you compose that to n equals to plus minus 1?
Yes, unless you don't know. So by the way, when I say n is equal to plus or minus 1, so as you see, I read it in this way. N is equal to plus or minus 1. You should be careful. This is an abbreviation for or, not and. If you know that, that's okay. So it's no problem. Okay, if I ask you the same question, but I change it to this. Determine, so everything as before, determine all integer n such that 0 divides 2n squared minus 2 minus n minus 1. So let me try to write it more properly, because it might happen that you don't have good answers. No, 2n squared minus 3n minus 2. So let me write it like this. So the first part I ignored. Determine all integers n such that this happens. Okay. Okay, I want to hear from you. If you want to solve that one, how do you solve the problem? But now you have 0 on the left. So 0 on the left is usually a bad sign, because 0 on the left will go to the denominator. Yes? And then when 0 goes to the denominator, I am in trouble. Unless you remember what we told in the previous board about this. So if you insist to have a true statement and have 0 on the left, what should happen? Yes, Maximilian?
The statement on the right should be equal to 0.
So the expression on the right should also be equal to 0, yes? Because you just learned here that if you have 0 on the right, so here, if you have 0 on the left, I have two cases that I have 0 on the left. In one of them, if I have a non-zero number on the right, it is always false. So this cannot happen. Yes? So in order to have 0 on the left and have a true statement, I have just only one option: to force the right-hand side to also be equal to 0. Yes? So that's what you need to understand, and then immediately write it down. So I would say that based on what I explained, you can conclude that 2n squared minus 3n minus 2 is equal to 0, and the other way around. And then this is a very simple problem. You have to solve this quadratic equation either using ABC formula or PQ formula. So from now on, I use the ABC formula, which is minus b plus or minus the square root of b squared minus 4ac divided by 2a, yes? These are the roots. So here, this number is a, this number is b, and this number is c. So what I write, I would say that n is equal to minus b, which is 3 plus or minus the square root of 9, plus 4 times 2, 8 times 2 is 16, and then divided by 2 times 8, which is 4. But no, 9 plus 16 is 25, 5, so I would write 3 plus or minus 5 divided by 4. And then what do I get? I get two possibilities with OR, of course. N is equal to 3 plus 5 divided by, that's 2, and then is minus a half. So it's not acceptable. Yes, so that is the only one that you have. So the answer will be n equals to 2. Yes?
Where did you get 60 from? 60.
4 times a times 2. Yes? 4 times this times that. Minus 4ac. Yeah. Is that clear? Okay. Okay, so let me ask you some questions here. Let me write as example this one as well. Let a, b, and c be non-zero integers. Which implication if any is true? So if you tell me that A divides B, and by the way, this is the symbol that I use for and. So this is or, and this I use is and, yes? If you tell me that C also divides B, can I conclude that A times C also divides B? Which implication, if any, is true? This is the first one. Let us just do it one by one. So I am telling you that I haven't told about my numbers A, B, and C, but I have given you two pieces of information. I tell you that the numbers that I have in my head satisfy these two conditions. A divides B, and also C divides B. Do you think I can jump and conclude the product of A and C also divides B? So the answer to this is twofold. Yes, either true or false. If it is true, you have to prove it. You cannot give me examples. Look, Babak, this example works, so this is true. If you want to prove that this is true, you have to give an argument for me so that this is working for all possible scenarios. But if you are willing to say, no, this is not correct based on your guess, you just need to provide me one single example that shows it doesn't work. And there is a particular name for this example in mathematics that's called counterexample. So you need to provide a counterexample for me. And now this is up to you to decide. If this is true, try to find the proper argument to prove it. If this is false, instead of trying to disprove in mathematics, you need to bring a counterexample. Okay, so you can think so that I am just cleaning the board. So let me also pause this recording, not being bored. Okay, what's your opinion? Yes, please.
I think it's false. It doesn't work.
So when you say it's false, then your duty is to bring me a counterexample. So it means that you need to provide me a triple, A, B, and C, so that the first statement is true, the second statement is also true, but the conclusion is false. This is the way that you have to think. Yes, everyone agrees? Okay, so what's your example then? So what you...
Now that I think about it, it might not work, but I'll say it anyway. I was thinking if b equals 10, so...
So let me just write B equals to 10. What about A and B? A and C?
Well, I just realized it might not work because
No worries, but just tell me, because if it's not...
that A would be 5 and then C would be 10, but I can't do that probably, I guess.
Yeah, so you see, A, that's also very instructive to talk about these things. So you said A is 5, what? C is 2, yes?
No, 10.
C is
So
10.
I can't do that, right?
No, but that's why it's not. So let us discuss about all scenarios. So you cannot say that. So if you go to the last statement, of course it is false, isn't it? Because what Rocco mentioned, you multiply A by C, what do you get? So you see, I am just trying to check this. I want you to learn these things. Okay? A times C is 50. So 50 divides B, which is 10. True or false? As a rule of thumb, I told you, divide 10 by 50. Is it integer? No, so it's false. But can I say this is a counterexample because the right-hand side is false? Why it's not a counterexample? Because the counterexample is exactly more or less the same thing. We want to show that the right-hand side does not happen sometimes. That's the meaning of counterexample, and apparently what Rocco provided is actually true because the right-hand side is false. But can I say this is a counterexample for the problem? Can you yourself answer that now?
No, because I said C is supposed to be a separate number.
Yeah, exactly.
So in that
No, not separate. That's not the problem. The problem lies somewhere else. You can choose all the numbers the same. It doesn't matter. Because in the statement of the problem, I haven't put any restrictions on A and B and C unless these two. So I am not saying that jump and conclude this for any numbers A and C and B. I am telling you that if this is true and this is true, then this is true. This is a claim that if these two are true, then the third one has to be true. But the example that you have provided, even though the right-hand side is not true, which is good, but you haven't respected these two to be true. Is that understandable? I want to keep the counterexample shows this implication is false. It means that you have to respect this, you have to respect this, and then show that no, it is possible that this is not true. If you don't respect them, there is no claim at all. It's not claiming this for any choice of A and B and C. It's claiming this if you respect these two statements. Yes, that's the claim. Yes? Is that clear? So the reason that this is not a good counterexample, even though the right-hand side is not true, because you are not respecting one of them or both of them, let us see, is A divides B. Is true or false? It is true. Oh, by the way, this is good. Yeah, extremely good example. That's a counterexample. Yes, I was a little bit confused myself. Sorry for that, Rocco. So C divides that's completely correct because you have respect. So you confused me yourself. Yes, yes, you confused me. Yeah. But the problem is that you have respected everything. A divides B is true. Sorry for that. And C divides B is also true. Yes. Let us check. 5 divides 10. True. C divides B. 10 divides 10. It's also true. So you really respected these two and showed us the conclusion is not working. So that is indeed a counterexample, sorry. But you yourself was confused because you thought that I have chosen A and B and C to be equal.
Oh,
no worry.
C and B to be equal.
C and B to be
I don't know
equal.
if
But there is no, you shouldn't be worried about that because it is not claiming anything about A and B and C. So it means that you can, sorry for that. Okay, so that's a good counterexample. So don't jump to conclusions and say that, okay, intuitively this is correct, so it works. But it's not working, yes? What about addition, do you think? If I have this scenario, Number 2. If I say A divides B and, for example, let me write A divides C. Can I conclude A divides B plus C? What do you think? Is it true or false? So I write one more here, and then I will let you to think for 5 minutes, then I come back to you. Okay, so let me write one more here. Let me change that a little bit. So instead of putting, so let me write number 3. If you tell me that A, B divides C, can I conclude that A divides C and B divides C? And number 4, if you tell me C divides A, B, can I conclude that C divides A or C divides B? Okay, I want you to take some time to think about these 3 statements. If you believe it is true, you have to prove it. If you believe it is wrong, you have to provide something like this, a counterexample. I want to give you a little bit of time to think. Because these concepts are not hard, I want to give time to you to digest the notations, thinking. You have to repeat these things in your brain over and over again so that you can get used to it. Yes?
You mean or in the fourth example?
I intentionally made here or, here and. Which one is weaker, or and? Or is weak here. So when you want to say that do this one or that one, you have less constraint for the person. But if you ask the person to satisfy this and that, you are demanding more.
Yeah.
So we'd say that or is a weaker condition. Okay. I will give you time a little bit. Okay. Any opinions about number 2? Yes? True or false first?
I would say it's true.
True? Okay, then your duty is a little bit harder, so you have to give me an argument why this is true. Yes, I agree with her. Let me check. Yes, that's true. Yeah?
Okay, I chose some numbers. I chose B to be 14.
No, but I have to interrupt you right now because I want to teach you something. This is not a good... I don't even want to listen to the rest. That is wrong.
Why?
No, because you are giving numbers, if I understand correctly.
Okay, I can.
It doesn't matter if you bring millions of examples that this work. It's not guaranteed that it will work for the next set of numbers. Yes, you have to bring an argument for me. Pardon?
Should I give? Can I give like a better explanation now instead?
I wouldn't consider the other one an explanation.
Or
So I am waiting for you for your explanation.
okay.
Yes.
Should I go on? Or
Yes, yes, of course.
I said that if B is divisible by A and C is also divisible by A, then addition of B and C creates a number which is a multiply of A, or better said, also divisible by A.
Okay, so that's what I'm saying. You are right. But the point is that we want to have a rigorous proof. What you are saying, more or less, you are repeating the same scenario. If you just explain the problem in different language, this might illuminate how to work it out, but it doesn't necessarily mean that you have provided an argument. So it should be based on what we have as definitions. For example, so one rule of thumb, if this is a multiple choice question and you want to see if this is true or false, just choose the rule of thumb. When you say A divides B, it means B over A, the fraction B over A is an integer. Yes? And then when you say A divides C, it means C over A is an integer. Yes? But what is the meaning of this sentence? The sentence is B plus C divided by A. And then you know from very elementary primary school thing, you can see that this is B over A plus C over A. Yes? And then B over A is an integer because of this guaranteed condition, and C over A is the same. And now I am, even though I am looking at two fractions, but these two fractions are actually they are not really fractions, they are integers based on this conception. So then it means that when I add them, the sum is also an integer. This is a rule of thumb to immediately understand if it is true or false. But if you want to write it properly, I prefer to write it in that way. You are telling me that A divides B. What can I conclude from this sentence? I can conclude that there exists a Q where in the set of integers how such that the number on the right is A, the number on the left times Q. Do you agree with this one? When you tell me A divides B, I am allowed to conclude this sentence, this statement, yes? That's the definition of this. And now you are telling me the same happens for A and C. So you are also telling me that A divides C. Then can I conclude what? I can conclude there exists a Q in where? In Z, how? Such that the number on the right, C, is equal to the number on the left multiplied by Q. Yes? Yes or no? What you see on the board, it contains a very small flaw. What's that? Yes?
It means that Q must be the same. Well,
Okay, exact. Thank you very much. So this is important to understand these things if you want to read math texts. So you see, when I say A divides B, I am allowed to conclude that there exists a number. Then I give it a name. I give it the name Q because this is the quotient usually, A over B. This is why we call it Q. And that's so far so good. But when I write the second term, I am saying that there exists Q in Z. And this is a standard in mathematics. In one problem, if I am using letter Q here and there, I mean they are exactly the same. So if I am using one letter in one problem, every appearance of that letter in the whole problem from the beginning to the end means the same number. If you ask me what that number Q is, I don't know. But when I write it in that way, I am forcing these two numbers to be the same. But there is no guarantee that these two numbers are the same. Yes or no? So this is why I have to change it to some other letter. I don't know. Let me put a prime on it. And please don't confuse this with derivative. It has nothing to do with derivative. I'm just changing a letter. You can just use T or whatever you want to. I just write Q prime. But another thing. Does this necessarily mean Q and Q prime are different?
No.
No. They might be the same. If I use two different letters, it might happen that the values assigned to them are exactly the same, but it is not necessarily the case. But if I don't put the prime here, I am forcing them to be the same. I'm not allowed to do that. There is nothing to say me to force them to be equal. So I put a prime here and I put a prime here. Now everything seems okay, yes? Now I understand what I'm going to prove. I am going to prove that B plus C is divisible by A. So it seems that I need this combination B plus C. I do not have that combination yet. I have to construct it myself. I want to have B plus C on the one hand, because I see it here. On the other hand, I don't have it. I want to construct B plus C somehow. How should I do that? It motivates you what? To do what? It motivates you to conclude what? B is equal to this, C is equal to this. You want B plus C. This motivates you to do what? Okay, come on, tell me. What should I do?
B plus C is equal to.
I have to add them side by side. I have B individually, I have C individually, but I want to have B plus C, so it motivates me. Add these two side by side, so it becomes B plus C equals to AQ plus AQ prime. Agree? Yes or no? Yes. Okay. Now I can simplify this a little bit. So this means that B plus C, I can factor A out, and what is left for me is Q plus Q prime. Yes? And now what happens? What is your opinion about this number? The Q part was an integer. The Q prime part was also an integer. So what can I conclude about the sum?
It's
What
an
type of
integer.
number? It's an integer. Yes? So I can call it a number capital Q, for example. So what I concluded that B plus C is A times Q, and Q is an integer. So what does it mean? B plus C is a multiple of A, is an integer multiple of A. So what does this mean? This means that B plus C is divisible by A. Yes or no?
Yes.
So that's the meaning. So that was true. So this is the way that you have to write it down. It's a little bit, might be cumbersome in the beginning to respect these symbols and notations, but that is the argument, yes? It's more or less what you wanted to say in words, but you have to write it in proper language. Any questions here? Okay, so here we are done. So this is true, and I want you to memorize that. It's a good rule of thumb. If two numbers are divisible by the same number, the sum of those two numbers is also divisible by the same number. Yes? What about subtraction, do you think? Instead of B plus C, if I write B minus C, what do you think? Is it true still or not?
True.
It's true, yes? Because what will happen, this will motivate you to subtract, and when you subtract, instead of having addition here, you will have subtraction. But Q minus Q prime is again an integer, so that's also true. So that's a good rule of thumb to remember.
Yep.
It's true. Okay, what do you think about the number 3? Yes, do you have questions regarding this?
The first one.
Yes?
Could you repeat the sentence you said that what you can conclude from that?
If two numbers
Yeah.
are divisible by the same number, then the sum and the difference of those numbers are also divisible by that number. Okay, so what about, do you have questions? Okay, what about the other part, number 3? So let me clean this one, we don't need it anymore. So what do you think about this one? I want you to be very quick in at least understanding if it is true or false by that rule of thumb. Yes? What's your name? Yala? Yana. Okay. So can you tell me, is it true or false first? True. Okay, so then you have a little bit harder work. You have to convince me why this is true.
Because C can only be divided by something less or equal to C, I think A and B individually are always less than C. So that means if you divide them by C individually, they're less. And also, I think it's a rule that you can always divide a thing by that it's multiplied.
It's very good that you actually talked about that, but that is not a good argument. What you said is this. Let me write. Assume that A and B are coming from N. I want to exclude the negative ones to make everything clear. So if A divides B, A and B are natural numbers, and I know that A divides B. What do you think? Can I conclude that what you said A is less than or equal to B? According to what you said, it is true. And I agree, it's true. If A divides B, A cannot exceed B. Yes? But are these two equivalent? Because what you are giving me as an argument, instead of proving this, you are trying to prove this. And if you prove this, can I conclude back? So that's the point. Do you think the other way around is also true? If that is true, yes, you are right. I have to agree with you. Do you think if A is less than or equal to B, I can go and conclude that A divides B? It's clearly not, yes? Because 4 is less than or equal to 6. But if I say 4 divides 6, it's not correct. Yes? So one way is true, the other way is not true. Yes?
Yes, but like already that it has to be something that it can be divided.
Oh, exactly. So what I'm saying that if you understand it, you have to write it in this way eventually. Yes? So what you are saying is this. You are saying that C is divisible by AB. As a rule of thumb, means CAB is an integer. Yes? Okay, now can you tell me why do you think C over A is an integer?
Because it can be multiplied by B so that it's either divisible or equal to C.
So that's what the reason that I'm emphasizing, because you know that some students, when they write the answer in the exam, they feel this is trivial or very simple, and then they explain the same thing and they try to. So what you need to write, if you want to write it in your way, so you should say that C over B is an integer. Why do you think C over A is an integer? Because you need to write C over A is an integer. So what you write, it's, by the way, is it true or false? Yes. So you need to, I don't know, you need to tell me why do you conclude that C over A is an integer? So do you understand what I mean? Because what you write is C over A multiplied by 1 over B. Yes? I know that this is an integer. This is for sure. I know that. And then you are claiming that if this is an integer, this has to be an integer. You see what I'm saying? It's still a little, it's simple. You are right, but it is not finished yet. So your claim, so you know that this is integer, and instead of this, everyone agrees this is a very simple algebra. Instead of C over A times B, I can simply write C over A multiplied by 1 over B. Nothing is wrong. But if you just write this and immediately jump to this conclusion, so we are done, I have to deduct some points from you. I just want you to understand. Forget about points or something. We want to understand things. It's not finished yet, unless you tell me why C over A is an integer. So you know that C over A is a number. You are multiplying by a fraction in which the numerator is 1. So more or less this is a real fraction. 1 over anything is more or less a fraction. And then you know the result is an integer. Then you jump to the conclusion that this should be an integer. I mean, there is a gap there. If I want to sell this to you, do you agree with me then? Do you buy it? Probably not. You have to prove it. Is that understandable? So and then the Math 5 thing, this is very important to understand how to write proofs and things like that. Okay. But how can you, yes?
I would go to the counter and say that it's false.
No, it is, so if you have a false, so please give me your counterexample then.
So if A is equal to 3.
So let us just, because if that is A is equal to 3,
B is equal to 2,
B is equal to 2,
and C is equal to 6.
C is equal to 6. Okay. So first of all, you have to guarantee this, because this is not claiming that A divides C and B divides C out of the blue. This tells you that if you give me this, then both of them are true. Let us check. So is it a good example? Yes, 3 times 2 is 6. Yes, this is true. But if I go here, what will happen? A divides C. Is it true or false?
True.
True, because 3 divides 6. What about this one? True or false?
True.
True. So you haven't provided a counterexample. You have provided an example which confirms that this might be true. Yes? 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 True or false?
False.
False. So counterexample.
So what if A is not an integer?
No. You are not allowed to do that because I have expressed that the A, B, and C are non-zero integers. And I told you in the beginning, let us not repeat it anymore. When we are working in number theory, if I want to mean something non-integer, I have to explicit. I have to be explicit. If I don't mention it, even though I have explicitly mentioned that there, You cannot give me those numbers. Okay. So true or false again? Might be I'm confusing you. It's very simple. First of all, how many of you believe that this is true? At least I want to check your intuition. Raise your hands if you think. Okay. So your intuition is correct. So this is really true. And this is, by the way, let us not make it hard. I have a number which is divisible by the product of two numbers. So it should be divisible by each one of them. Isn't it clear? No, it's not. Okay. So you have a number which... So I have two numbers, I multiply them, and I have another number which is divisible by this product. It is divisible by the product. It's very clear for me that it should be divisible by each one of them. But you agree. I agree with you. Might be you say that it's not trivial for me. You are right. Might be we need a proof. That's what I'm saying. We really need a proof. And this is not finished yet. It is not wrong. It's not finished yet. But if you don't mind, let me go back and try to write it in that way. So you help me to write this. So I want to go for the truth. I believe that this is true. I try to prove it. Okay? I would say that AB divides C. Okay, tell me, what can I conclude? Everyone tells me how to write it down. What should I write mathematically? There exists, yes? There exists what? A Q where?
Belongs to Z.
In Z, such that what happens? The number on the right is equal to the number on the left, which is this guy, multiplied by Q. This is what I know, yes? But you are telling me that C is AB times Q. Let me ask you, can I conclude this, that C is equal to A times BQ? Do you agree with this one? Do you agree that from this equality, I can also take the pair of brackets and put them around them and conclude this equality? Do you think that's a valid step? Yes, because A times BQ is exactly the same as AB times Q. Yes? But what type of number you see here? What's that number? B is already a non-zero integer expressed in the problem. What type of number Q is? It's an integer. So B is an integer, Q is an integer. If I multiply two integers, what the answer is? It's an integer again. And now what happens? C is A multiplied by an integer. So what can I conclude about divisibility of A and C? A has been multiplied to an integer and it generated C. So what does it mean? A
Is an integer? No.
No, A is already an integer.
Okay.
Yes? A multiplied by an integer, I get C. What is the conclusion? Come on. Come on. So A multiplied, so 2 times 3 is 6. What can you conclude about the divisibility of 2 and 6?
They are divisible.
Yes. So A multiplied by an integer is equal to C. So this means A
Is
divides C, or C is divisible by A. Yes? Is that understandable or not?
yes.
It's just nothing actually. Yes? It's actually a good place to learn how to write. But is the problem finished? No, because the problem, the conclusion is 2 parts. Contains 2 parts. I was able to guarantee this one. But can I also guarantee this one?
Yes.
How?
You just do the same
I go
trick.
back again here. Instead of concluding it in this way, what do you think I will write here now?
B,
B times
AQ.
AQ. But A is already given to be an integer. Q is also an integer. So the product is an integer. So what can I know about this product? Also belongs to Z. Now C is B multiplied by an integer. What can I conclude then? No. B divides C. C is divisible by. And now I am done. So that is also a good rule of thumb. You need to know if a number is divisible by a product, it's divisible by each factor individually. Yes?
Can you say that one more time?
If a number is divisible by a product, it's divisible by each factor individually. Yeah, is that clear? Yes or no?
Yes.
Okay. Now, you have a little bit more experience now. And now we want to talk about this scenario. This is telling you that if you have a product which is divisible by a number, at least one of these should be divisible. Otherwise, it will not work. So, if you think it is true, you need to prove it. Like this argument, you see, I haven't brought any numbers in because I was trying to prove it, so I'm not allowed to give particular numbers. I have to give you arguments, provide arguments for it. But in this case, if you believe this is true, you have to give me like this, an argument. If it is false, you need to bring me a counterexample which does not work. What does it mean it does not work? It means that this is true, but at least one of them, none of them is true. Yes? This should be true, but none of them should be true. Because even if one of them is true, this is or, and I am done. Yes? None of them should be true. Okay, now, so Hadia, true or false?
False.
False. What's your counterexample? A is 4.
B is 3.
B is 3.
And C is 6.
C is 6. Let us check. If you say this is a counterexample, you have to respect that this should be true. Is it true or false? A times B is how much? 12. 12 is divisible by 6. True. Yes, you are right. This is true in this case. But let us check this one. Is this true? C divides A. True or false? False. Yes, false. Okay, we still don't lose the hope. Is it false or not? False. So you see, even though, so that's correct. That's a good answer to this problem. So you should say it is false since if I choose A to be 4, B to be 3, C to be 6, this is true, but none of them is true. So you are right. So I cannot rely on this. Okay? So you are right. So you see that sometimes it is not that easy, so you have to think a little bit to see if it is true or false. If it is false, try to bring a counterexample. Don't try to give me stories. It doesn't matter how many. So this is why I can correct papers quickly, because when I see that you are saying it's false and then bringing argument, I even don't bother to read it. There is no way. You have to bring a counterexample to falsify something, to refute something, yes? But now, so this is good to understand these things. I think I can stop here. It's a good point. It's not finished. I will continue a little bit more. We have more interesting problems. I gave you the promise to give you time practice in the second session. I still stand for it, okay? So I will write on Google Classroom. So the next session I will not teach, you will practice, okay?
Mr. How can the mathematics check if the
No, this is not, what do you mean? This is mathematically false.
doing the whole process?
No, that's what I'm saying.
But in the exam, do you need to do the whole process?
No, that's the point. If this is given in the exam and you're supposed to say this is false, that is enough.